So today we're going to kind of put a bunch of different things together, okay? It's called Polynomial Connections, and just like that title indicates, we're going to make some connections among all the different things that we've done, okay? So the first thing we're going to do is, instead of finding roots or zeros, we're going to be given some zeros, and we are going to have to turn that into a polynomial, okay? So we're going to start off nice and easy, and we've got only real zeros. So do you have some ideas on how we could start to turn this in, Emily? Perfect. We're going to take these roots, we're going to turn these roots into factors, and then we're going to multiply it out. Okay, Leah? Okay, good. We know that we are going to have a cubic function. Great. All right, so let's talk about how do I turn a root of 3 into a factor? What's it going to be? Good. It's going to be x minus 3, because if I set that equal to 0, that's what will give me 3. How do I turn negative 1 into a factor? Good. And what about 0? That's just x. You okay if I come back over here and put the x here? Because that's normally how we're used to seeing it. Okay? So we have x times x minus 3 times x plus 1. So now we're going to do some multiplying. Okay? So let's multiply x minus 3 times x plus 1 first. So take a second and go ahead and multiply that out. Did you get x squared minus 2x minus 3? All right, and now what are we going to do with that x? We're going to distribute that x. So we're going to get x cubed minus 2x squared minus 3x. Excuse me. Whoa, that's bad. That's your answer. Having trouble boxing it. Okay? Any questions over what process we just used? All right. So let's try one with not all real rational roots. Okay? Let's look if we were given a root of 1 and a root of 2i. Tell me what you know about imaginary roots. Okay, they're not real roots. They don't cross the x-axis. What else do you know about them? Yeah. Okay, yeah, just like they don't cross the x-axis, we can't plot them. Does anyone remember anything when we talked about how many imaginary roots you can have? Yeah, they come in pairs. Whenever we get an imaginary root, we always get plus or minus, right? Imaginary roots have to come in pairs, okay? So if I have a root of 2i, I also know that I have a root of negative 2i. Okay? So you might want to write yourself a rule over here. Imaginary roots come in pairs.
How would you have negative 2i? Isn't I negative 4 or square root negative 1?
It's just like if you were, what do you get if you say x squared equals negative 4? Plus or minus 2i, because anytime you take the square root, you have to do plus or minus. Okay? Imaginary roots have to come in pairs. Okay? After we realize that fact, we're going to treat this just the same. How do I turn a root of 1 into a factor? Good. X minus 1. I want to get 2i into a factor. So just like I did with 1, this is going to be x minus 2i. Now, what if I'm subtracting negative 2i? What does that become? Yeah, x plus 2i. All right, so now we get to do a little practice with multiplying. The hardest part here, guys, is going to be keeping track of your negatives and keeping track of what you're multiplying. So you just have to take it slow and go step by step because we know how to multiply. We just have to make sure we don't lose anything along the way, okay? Let's start out by multiplying x minus 2i times x plus 2i. So I'm going to go ahead and just bring down my x minus 1. And then I want to multiply these. Okay? All right, so x times x, x squared. X times 2i, 2ix or 2xi, whichever way you want to write it. No, it would be 2ix, sorry. Negative 1 times x. Oh, no, sorry, we're doing these. Negative 2i times x. How about that? Negative 2ix. Negative 2i times positive 2i. Very good. Negative 4i squared. All right, what do you notice? Yeah, our two middle terms cancel. And what is negative 4i squared? Yeah, that's negative 4, which turns into 4. How do we know that? What is I squared? I squared is negative 1. So that's negative 4 times negative 1. So what do I have left? X squared minus 1 times x squared plus 4. Take a second and multiply those. And go ahead and write it in standard form. X cubed minus x squared plus 4x minus 4. Did you get that? All right, good deal. That is as far as we can go. That we have now put a polynomial in standard form that has those roots. Questions? All right, look at the next one. We've got a root of 3. We've got a root of root 2. Okay? Now, anytime we see square roots in our answers, what do those normally come with too? Plus or minus. Yep, those normally come with a plus or minus as well. So this is another one where our square roots come in pairs.
So would it be square root of -2, or would it just be minus square root?
Right. Because we think about plus or minus the square root of 2. So we've got plus the square root of 2, and now we're going to add in minus the square root of 2. Okay? So let's turn these into factors. What would be my first factor? X minus 3, good. What's my next factor? Good. Then all right. Let's go ahead and multiply out our second 2 first. So I'm going to rewrite x minus 3. X times x is x squared. X times root 2. Negative 2 times x. And negative root 2 times positive root 2. What's it going to be? Negative 2. Good, because it's going to be negative the square root of 4, so it's going to be negative 2. All right, what do you notice? Yeah, the middle 2 cancel out. We're going to have x minus 3 times x squared minus 2. Do you notice a pattern? Okay, good. When? Well, yeah, when we have to add the plus or minus, okay? Remember, just for a second, just over here for a second, you don't have to write this down necessarily. What does a squared minus b squared factor to become?
A minus b, a plus.
Okay, so notice that we had x minus root 2, x plus root 2. X minus 2i, x plus 2i. Okay, we had an a plus b and an a minus b. Okay, so when you multiply them together, you can do the difference of squares backwards. Okay, your middle term, notice there's no middle term here. There's no AB term or anything like that. Those go away. So those should always fall off if you're adding in one of your negative pairs or your positive pair. Okay? All right, so let's finish this one. Let's distribute my x. If I distribute x, I'm going to have x cubed. X times negative 2 will be negative 2x. Then negative 3x squared plus 6. Rewrite that in standard form. X cubed minus 3x squared minus 2x plus 6. Oh, yeah. I missed that x, didn't I? Right. On number 2, that should be a 4x. Thanks, Emily. Everyone okay so far? Okay, one more rule. If I have roots of 3 and then 2 plus I, what kind of number is 2 plus I? It's complex. It's got a real part and it's got an imaginary part. Okay? A complex number is always going to come in pairs with its conjugate. What is the conjugate of 2 plus I? 2 minus I. So that is the missing root here. Okay? So your little rule to yourself is that complex roots always come with their conjugate. Okay, so the signs on this one get a little tricky because on the other one we had x minus root 2 and x plus root 2. But we're not changing the sign of the one in front. It's becoming the conjugate now. All right? So how do I write 3 as a factor? X minus 3. Now in order to get 2 plus I as my root, does anyone know what my factor is going to have to be? It's going to be minus 2 plus I, but you've got to put parentheses. And again, we're going to have x minus, and we're going to put our 2 minus I in parentheses. Yeah, let's go ahead and simplify those factors, okay? So I'm going to have x minus 3, x minus 2 plus I. What's that going to become? X minus 2 minus I. Good. X minus 2 minus I. Good. Does everyone see what I'm doing right now? Yeah? Okay. Let's multiply those long ones first. X minus 2 minus I, x minus 2 plus I. So I'm going to distribute my x to everything. X times x is x squared. X times negative 2, negative 2x. X times I. Yeah, we'll say ix, but yeah. Now distribute your negative 2. Negative 2 times x is going to be negative 2x. Negative 2 times negative 2 plus 4. Negative 2 times I, negative 2i. Now what are we distributing? Bless you. We're distributing our negative I. So negative I times x is going to be just negative ix. Negative I times negative 2? 2i. Negative I times positive I. Negative I squared. All right. Let's see what we can simplify here. All right, so we have a plus ix. We have a minus ix. So those can go away. Is there anything else we can cancel out? Yep, negative 2i and positive 2i. Yeah, what does negative I squared become? 1. Good, because we have negative 1, which is just going to be plus 1. So tell me what canceled out. All the i's. All your i's should cancel because this is not a problem that is given to us in imaginary numbers. Anytime we see a polynomial, it's only got real numbers in it. Okay? So all your i's should cancel out. So I could rewrite this as x minus 3. Then I'm going to have x squared. Combine your negative 2x's, and what does that give you? Negative 4x plus what? 5. All right, and now go ahead and multiply again. So would you take a minute and multiply x minus 3 times x squared minus 4x plus 5? All right, so in standard form, what'd you get?
X cubed minus 7x squared plus 17x minus 15.
Very good. Questions? All right. So now we're going to move on to a little different idea, okay? We have roots here. We've been practicing with roots that aren't real, okay? We've been practicing with some irrational, some imaginary, some complex. Irrational numbers are real numbers, but they're not real rational numbers. So let's practice factoring, okay? We've had a lot of practice with factoring, and we're going to go just one step further than we had gone before, okay? So tell me what you notice when you see this. X to the 4th minus 81. Good. Difference of squares. How does this factor? No, not quite. Yeah, x squared minus 9, x squared plus 9. Okay? Do we stop here? No, we can go another step. What else factors? So this will be x plus 3, x minus 3. And then we have x squared plus 9. Okay. So this is factored completely over the rational, real numbers. Okay? But today we're going to keep going. We are going to factor this completely, just completely. It's going to all have only x terms. No x squareds, no x cubes, nothing like that. Okay? Now, here's how we're going to do that. Okay, you might want to write yourself a little note that this was previously factored. This was factored over the real numbers. but we're going to keep going. So we're going to take this x squared plus 9, and we're going to figure out what roots come from it. Okay, so come down over here, or over here. It doesn't matter. Go wherever you want. Okay, x squared plus 9 equals 0. I'm going to find the roots. Subtract your 9 from both sides. X squared equals negative 9. What does x equal? Almost. Plus or minus. Good. So if I know I have a root of plus 3i and a root of minus 3i, can I write those as factors? Okay, so I'm going to come down. I'm going to try this again. I'm going to keep my x plus 3 and my x minus 3. But now, what are my other two factors?
Minus 3i plus 3i.
Good. X minus 3i, x plus 3i.
If you have a sum of squares, would it always equate that with an imaginary number?
All right, so this is now factored completely over the complex numbers. All right, ready for our next one? X cubed plus x squared minus 3x minus 3. Ideas on how to start this off. Okay, we're going to factor it by grouping. We got 4 terms. They look like they factor, so let's try them. What are we going to pull out the first 2 terms? What's going to be left? And out of the next ones? So this is where we would have stopped previously. But this is not factored completely. We still have an x squared term. Okay? So we're going to take the one that's not factored completely, x squared minus 3, and let's find the roots. X squared minus 3 equals 0. X squared equals 3. So what does x equal? Very good. Plus or minus the square root of 3. So if we keep factoring, we'll have, what would my factors be?
X plus 3 to 3, x minus 3 to 3.
And what else? X plus 1. What's a quick and easy way to check to see if you forgot your plus or minus? Not quite. Huh? That would be one way to check, but I'm talking even easier. Yeah, what's the degree of this polynomial? 3. So if you just wrote the square root of 3, you would have just had this. Or, sorry, that. Okay? So you would have only had 2 factors, but a degree of 3 polynomial. Okay? So that should help you check yourself. Did I remember to put them all in there?
So you always need as many factors as the degree.
Yep. Exactly. Really? All right. Let's find the roots of x to the 4th plus x cubed plus 2x squared plus 4x minus 8. Do we know how to factor this? I sure don't. 5 terms, I don't know what to do there. Yeah, so in order to get us started, we're going to have to do the P over Q thing, okay? So let's list out what is going to be on my top row. What goes there? Good, the factors of the constant. So for negative 8, I'm going to have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And that's going to be over plus or minus 1. So really, what's my list? Yeah, the top row. Anytime you got plus or minus 1 on the bottom, you can just go ahead and call that your list. All right, so I want to look at our graph to give us a little hint about this. Okay? So you don't have to get out your calculator. I've got this one up here. We can use this. So read me, if you would, our polynomial. And you guys watch my typing. Make sure I don't make a mistake. Okay, keep going. How'd I do? Okay? All right. Zoom 6, always start there. Okay, but I can't see very much, right? Did I type that in right? Doesn't quite look like I want it, but that's okay. All right, let's zoom out a little bit, see if we can get a little better picture of this. Nope, that just made it worse. So we'll zoom 6 it again. All right, so ideas on what we could try. -2, okay? What do we get from our picture? Okay, we see 2 intercepts. What does that tell us? 2 real roots. So what are our other roots going to be? Probably imaginary. Okay, so let's try -2. I think that's a good idea. Oh, I need to go back over here. Sin divot. 1, 1, 2, 4, -8. Does it work? Yeah. So -2 definitely works. Based on our graph, what else should we try? 1. So I'm going to try it with the coefficients that I have remaining here. Oh, gosh. Does 1 work? Yeah. How many real roots did we say we had? 2. So should I keep trying synthetic division? No. Why else should I stop synthetic division here? Yeah, we've reached a quadratic. What is that quadratic? X squared plus 4. Set that equal to 0. Let's find our roots. X squared equals -4. What does x equal? Plus or minus 2i. So our roots are -2, 1, and plus or minus 2i. Do I have the right number of roots? Yep, 4 roots. Questions? All right, real quick before I let you start on your homework. What if I had a graph, which is what this was supposed to look like, because I don't know what I did wrong. What if I had a graph that looks like this? Yeah. At this root, what do we know? Good. So if you were doing synthetic division with that root, how many times should you do it? Twice. Okay? So use your graph to help you. It might guide you to do synthetic division more than you might have. Okay? All right. I'll go back so you can make sure you have the homework copied down correctly. Notice that 25 through 31 is odd. 25 through 31 are just the odds.